So similar polygons are polygons with the same shape but a different size. So they're exactly the same shape, but their sizes are different. So one is going to be larger than the other. Basically, a dilation would be an example of similar polygons or similar figures. Now, polygons are similar if their corresponding angles are congruent or the same. So what makes them the same shape is that they have exactly the same size angles in the same places. So the corresponding angles are congruent, but they're going to be different sizes, so their sides are not congruent. Their sides are actually in proportion, and they're in proportion according to their scale factor. And the ratio of the corresponding sides is called that scale factor. And we looked a lot at scale factors when we were working with our dilations. So if polygons are similar, then their sides are proportional. All right, so scale factors. Here we have two triangles. We have triangle ABC, we have triangle DEF. All their sides are labeled. We know that their corresponding angles are congruent. Those are marked in the picture. So those two triangles are similar. What we want to try to do is figure out the scale factor of triangle ABC compared to the scale factor of triangle DEF. So if we look at a pair of corresponding sides, I'm going to just pick 8 and 12. That's one pair of corresponding sides. If I write those as a ratio, so I can compare the 8 on triangle ABC to the 12 on triangle DEF, if I then go ahead and reduce that, 8 divided by 12, or reduce both the 8 and the 12, I end up getting 2 to 3. So they're in the ratio of 2 to 3, which means that the scale factor would be 2/3. Which makes sense. This triangle right here is 2/3 the size of that one. Now, we could look at it in a different way too, because we don't have primes on here, so we don't know which one is first and which one is second. With this one, if we look at DEF compared to ABC, and we take the same two pair of sides, we're comparing 12 to 8. So the order matters here. Now, when we reduce that, we get 3/2, or if you're happier with the decimal version, 1.5 or 1.5. So going from triangle DEF to triangle ABC, that triangle is going to be 1.5 times the size of the other one. So what is the ratio of the perimeters? Well, remember, perimeter is what you get when you add up all the sides. So on the small triangle, if we add 8 and 10 and 14, we get a perimeter of 32. On the bigger triangle, if we add up the 12 and the 15 and the 21, we get a perimeter of 48. And so what we want to do is write the ratio of the perimeters of triangle DEF. So triangle DEF had a perimeter of 48 to triangle ABC, which had a perimeter of 32. So now, if we reduce that, 48 and 32, when we simplify that, we get a ratio of 3 to 2, which again would make our ratio or our scale factor 3/2 or the 1.5. So if the sides have a certain scale factor, the perimeter is going to have the exact same scale factor. All right, so similarity statements. If I want to say that something is similar to something else, the symbol is just that kind of squiggle. Like we saw that with our congruent sign. Congruent sign was an equal sign with that squiggle on the top, which means that they're congruent and similar. So similar is just that squiggle. So if I want to say that two triangles are similar, I have to make sure that I match up the corresponding angles and the sides. So on this triangle, if I want to say that triangle ABC is similar to this other triangle, I have to be careful and I have to match things up. So if I started out with A when I was naming this first triangle, I have to start out with D in the second triangle because those angles match up. Then I went to B, which has the two arcs, and it matches up with angle E over here. And then angle C matches up with angle F. So I would have to say triangle ABC is similar to triangle DEF. All right, so down below what we're going to do is we're going to list the corresponding angles and then we're going to write the sides in proportion. So in this figure right here, it appears that if I have JKL, triangle JKL, is similar to triangle PMN, that means that angle J, this angle here, is going to match up with angle P. Angle K is going to match up with angle M, and angle L is going to match up with angle N. So I have to use the similarity statement that they gave me to come up with those congruent angles. And now I just have to write them down here. So angle J is congruent to angle P, angle K is congruent to angle M, and angle L is congruent to angle N. Remember, the corresponding angles are exactly the same size, corresponding angles are congruent. The sides, though, are going to be in proportion. So this side right here corresponds to that side right there. So JL compared to NP should be in the same proportion or in the same ratio or have the same scale factor as any other pair of sides that I'm going to compare it to. So the next set would be JK and PM. And then the last set, KL, and I can compare that to MN. And so the corresponding sides are in proportion and the corresponding angles are congruent. Okay, so see if you can do that same thing with the second picture. In this case, we have overlapping triangles, so it might help you to take the two triangles and separate them first before you start to pick out the sides and the angles. All right. All right, on the back, we're going to do the same thing with number 3, except this time instead of triangles, we have quadrilaterals, but same idea. The corresponding angles are going to be congruent, and then we want to write one big, long corresponding sides proportion. Okay, so here's what we're going to look at next. Similar figures. With similar figures, basically, most of the time what they're going to do is have you solve for some missing sides. So if we take a look at number 4, it says, if the figures below are similar with a scale factor of 2 to 3, find the missing value of x. So that means that this one here is the 2 and this one here is the 3. So I know that they're in the ratio of 2 to 3, and I know that the actual measurements on this side happens to be a 42, but I don't know what the measurement on that side is. So I can set up a little proportion comparing 2/3 to 42 over what I'm missing. And then I can go ahead and cross multiply and solve for the missing length. Another thing that they might do is not necessarily give you the scale factor, but give you some actual measurements. So in this problem, we're told that triangle ABC is similar to triangle DEF. So that means that angle D matches up with angle A, angle B matches up with angle E, and angle C matches up with angle F. And so that might just help you to figure out where things are. So the sides that match up, this side right here that's labeled X, goes from angle A to B, so from 1 arc to 2. So that's going to match up with the 25. And then over here, the 28 on this triangle is going to match up with the 20. And so then I could set up a proportion. I could compare the X on this triangle to the 25 on that one. And I could compare the 28 on that triangle to the 20 on that one. Now, notice I went from big triangle to small triangle in my first fraction, and my second fraction was the same thing, big triangle to small triangle. As long as your proportion is consistent, it should be okay. I could have also compared the x and the 28. So I could have done x over 28. So this would be the longer side over the shorter side. And then on the other triangle, I'd have to match them up in the same order. So I'd have to do longer side over shorter side. And either way, either one of those proportions, I should still come up with the same answer. All right, so go ahead, try those, set up those proportions, solve those equations, see what you get for those answers, and we'll take a look at it tomorrow.